Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to everyone. Thank you for joining us for the public engagement session today. Can see more than 10 participants already logging on to the Zoom application. Thank you very much for your time today. Just a technical check. Can everyone hear me well? Maybe you can share, can chat on the chat box, type in yes. All right, great. Thank you, Ain. Thank you, Zuleika. For your information, we are also going live on our official Facebook page. Therefore, in case you have colleagues or friends who would like to view the session on Facebook, they can also do so by checking out our Facebook page. Just search for MTSFB and click on the live link to start viewing. When we will start the session in a moment, hopefully by sharp at 10 a.m. Thank you very much again for joining us. Bismillahirrahmanirrahim. Yang berusaha Puan Zaliha Abu Bakar, General Manager Malaysian Technical Standards Forum Berhad or MTSFB. Yang berusaha Dr. Ahmad Zaki Muhammad Saleh, Chairman of the Broadcast Technology Working Group. Yang berusaha Encik Muhammad Azmi Muhammad Zahid, Draft Lead Broadcast Technology Working Group and his team. Members of Broadcast Technology Working Group, representatives from the industry, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. Welcome to the public engagement session for the draft technical code titled Prediction and Measurement of EMF Exposure from Terrestrial Radio and Television Broadcasting Transmitter Stations. I am Shafina, your host for today's event. For those joining us on the Zoom application, thank you very much for participating in the session live on our official Facebook page right now. To kickstart our event today, I would like to invite Yang Berusaha Encik Muhaimin Mat Saleh to lead the doa recital. Encik Muhaimin, the floor is yours.
Okay, thank you Puan Shafina. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Segala puji bagi Allah Tuhan sekalian alam. Selawat dan salam ke atas junjungan besar Nabi Muhammad sallallahu alaihi wasallam dan ke atas keluarga serta para sahabat baginda sekalian. Ya Allah, ya Karim, ya Wadud, berkati dan rahmatilah majlis public engagement pada pagi yang penuh berkah ini. Satukanlah hati-hati kami dalam usaha memartabatkan bidang standard ini di dalam kehidupan seharian, khususnya di bidang komunikasi dan multimedia di Malaysia. Ya Allah, Kau permudahkanlah segala usaha-usaha kami di dalam menyokong industri komunikasi dan multimedia ini bagi memelihara dan mendukung kepentingan negara. Berkatilah segala usaha kami di dalam menjadikan organisasi MTSFB ini sebagai sebuah organisasi yang cemerlang, disegani dan dihormati oleh semua orang. Semoga dengan usaha ini, MTSFB mampu menghasilkan kod-kod teknikal yang berkualiti dan bermanfaat bagi seluruh industri komunikasi dan multimedia di Malaysia pada masa kini dan masa akan datang. Ya Rahman, Ya Rahim, Ya Rabbal Alamin, perbaikilah segala kesilapan dan kelemahan kami, serta tunjukkanlah kami jalan kemajuan, kemakmuran dan kesejahteraan. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wassallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi barik wasallim. Walhamdulillahirabbil alamin.
Amin, amin, ya Rabbal Alamin. Thank you, Cik Muhaimin. We sincerely hope that today's event will be easy and blessed. Ladies and gentlemen, to start the order of the agenda today, I would like to invite Yang Berusaha Puan Zaliha Abu Bakar, General Manager of MTSFB, to deliver her welcoming speech. Please welcome Puan Zaliha Abu Bakar.
Okay, thank you Puan Fina. Thank you so much for officiating starting today's event. Bismillahirrahmanirrahim. Yang Berusaha Dr. Ahmad Zaki Muhammad Saleh, Chairman Broadcast Technology Working Group ataupun what we call BT Working Group. Yang Berusaha Encik Muhammad Azmi Muhammad Zahid, Draft Lead of our BT Working Group, members of BT Working Group and MTSFB team, representative from the industry, ladies and gentlemen. Assalamualaikum and a very good morning to everyone. Alhamdulillah, it is kind of, this is the first public engagement for MTSFB in the year of 2021. We are doing it virtually. I'm also seeing myself. I can't see you guys at the end of this session. So if you're on FB, share us with your emoticons saying that you are with us today. Because I see there's about almost 20 of us online now on FB. First and foremost, I would like to welcome everyone, especially Yang Berusaha Dr. Ahmad Zaki and BT Working Group members for making time for this session. And Dr. Zaki, beside your busy schedule, you are with us today. Thank you so much. So on behalf of MTSFB, we are indeed honored to have all of you here at another milestone in this crucial event whereby it is a part and parcel, very key milestone in TC development process in MTSFB. Ladies and gentlemen, this public engagement exercise is part of the overall public comment activity, which is very key. It is a very, very key component of our technical code development at MTSFB. This process is important to ensure that the technical code document being developed is created in good faith and taking into consideration comments from other industry players as well as the public. Neutrality is a key element in creation of technical codes and standards. Therefore, as much as we can, we will gather feedback from various parties to strengthen the technical codes that develop here in MTSFB. In other words, we do not want to create documents based solely on our own interpretation. So we don't want to do a short scenery kind of development. So we are more happy to receive comments and feedback to live up to the quality of the documents to be produced. We in MTSFB hope that this public engagement session provides a more interactive platform for the public to give feedback and to learn more about the draft technical code being discussed. At this point, I would like to express my heartfelt appreciation to the BT Working Group for their dedication and commitment in getting the draft technical code for the prediction and measurement of EMF exposure from terrestrial radio and television broadcasting transmitter stations to be realized up to this stage. Just a little bit more. Now, before we can complete the document and submit it for registration, therefore, again, I would like to again thank the BT Working Group for sharing your expertise and moving forward with the draft technical code. Same goes to my team, MTSFB, who has diligently, industriously working together with BT Working Group to come to this point of the development. Ladies and gentlemen, before I conclude my speech, I would like to request for all of you present here to actively contribute either through the session today or through the online public comment form that we will open until 15 March this year, 2021. Your contribution is very valuable to us and very much appreciated. In addition, we will be organizing many more public comment exercises and many engagement sessions for other technical codes as well. Therefore, it will be great if you can continue supporting us, and we look forward to seeing more of your participation in our future events as well. With that, thanks again for joining us today and looking forward to a fruitful and meaningful engagement session. Thank you.
Thank you, Puan Zaleha, for the warm welcome. Ladies and gentlemen, next, I would like to invite Yang Berusaha, Dr. Ahmad Zaki Muhammad Saleh, the Chairman of the Broadcast Technology Working Group, to say a few words. Please welcome Dr. Ahmad Zaki Muhammad Saleh. I hope Dr. Zaki is not experiencing any technical glitches on his end.
Okay, sorry.
All right, great.
Okay.
Thank you, Dr. Zaki. The floor is
Okay.
yours.
Sorry. I was told that the controller will control the muting and the camera. Sorry, so I didn't touch. Okay. Anyway, apologies for that. Okay. Bismillahirrahmanirrahim. yang berusaha Puan Zaliha Abu Bakar, General Manager Malaysian Technical Standards Forum Berhad, MTSFB. Yang berusaha Encik Muhammad Azmi Muhammad Zahid, Draft Lead of our BT Working Group. Members of the Broadcast Technology Working Group and MTSFB officers who have been involved with all our meetings. Representatives from the industry today. Ladies and gentlemen, Assalamualaikum and good morning to everyone. Firstly, I would like to thank Puan Zaliha and her MTSFB team for organizing this public engagement session in support of the draft technical code on prediction and measurement of EMF exposure from terrestrial radio and television broadcasting transmitter stations that will be presented and discussed today. So I really hope that we can get good participation, ideas or any comments from our members today. As mentioned by Puan Zaliha, I'm also excited and looking forward to be actively engaging myself in this session today. Okay, ladies and gentlemen, a little bit of background to the journey to where until we have arrived here today. Okay, we started the development activities of this technical code or TC as we call it since September last year. Okay, so it has been a long journey, and there was very I have to thank my members, BT Working Group members. They have been actively participating, and as a result we have come up with this document today. On average there are 16 members attending, I think more than 8 meetings, and our most recent meeting is actually on the 4th of February this year, and I have to say that I'm extremely pleased with the attendance and the level of participation in my working group to achieve this document today. Okay, now this document this was developed as a continuation to the submission on draft TC on EMF exposure for base stations. That's for the telcos. So this one is specific for the broadcast industry. And I hope this TC will serve as a main reference for broadcasters to conduct simulation and measurement of exposure of their transmitter stations in line with the exposure limit, which is also important for compliance purposes. So ladies and gentlemen, okay, EMF exposure is increasingly become more important considering the heightened sensitivity. I think everybody is talking about electromagnetic effect on health and so forth. So I think increasingly this document will become more relevant and more important. Although it is just a technical code, but I think I believe that it has been referenced by other documents in the stable of documents that we have. So we hope that the development of this TC will be accepted and duly registered by MCMC, not only for compliance stakes, but also to ensure the safety of our environment in the country, especially in the broadcast industry today. Okay, ladies and gentlemen, I have to thank my working group again and the members for their commitment and development of this document at this stage. So I have to thank them again. It is such a pleasure working with all of them, and I hope that we can move forward to make sure that this document goes through with the comments and feedbacks gathered today for registration and implementation. The journey is yet to end. Okay, it will continue, and we will hopefully work together to achieve more success in the future. For the participants of the session today, I really do hope to really tap on your ideas, your intellectual comments, and based on your experience, I can see a lot of faces which I have met before, and most of you are so well versed with the industry, and I really hope that you guys can give your inputs today. Okay, and of course I have to also express my thanks to our experts who have been developing the document, particularly Encik Azmi from MyTV, Dr. Imran from UTEM, Puan Roha from Nuclear Agency, and of course the rest as well, everybody in the BT document. So I think that's all. thank you very much again, and let's hope for a fruitful and productive meeting today. Thank you very much, and over back to you, Puan Syafina. Thank you.
All right. Thank you, Dr. Ahmad Zaki, for the kind words. Ladies and gentlemen, in order to explain more about the draft technical code that we are discussing today, I would like to invite Yang Berusaha Encik Muhammad Azmi Muhammad Zahid, the draft lead Broadcast Technology Working Group, and his team of experts, Yang Berusaha Dr. Imran Muhammad Ibrahim, and Yang Berusaha Puan Roha Tukimin, to deliver a briefing on the technical code. Please welcome Encik Muhammad Azmi Muhammad Zahid and team.
Thank you, Puan Safida. Bismillahirrahmanirrahim. Yang berusaha Puan Zalia Abu Bakar, General Manager Malaysian Technical Standard Forum Berhad. Yang berusaha Dr. Zakri Muhammad Saleh, Chairman Broadcast Technology Working Group. Members of Broadcast Working Group. Members of MTSFB. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, thank you. First of all, thank you MTSFB for giving me the opportunity to present in this public engagement for the prediction and measurement of EMF exposure from the terrestrial radio and television broadcasting transmitter station. Okay, actually this technical code is a sequence of the prediction and measurement of EMF exposure from base station for the mobile television base station. Internal exposure that has been developed last year. So since there is a request from NCMC to include also in the broadcast for the EMF radiation, then so the MTSFB with the broadcast technology working group has established a group to develop this technical code. Okay, so this is actually for the as mentioned by our broadcast technology working group chairman. So this the importance of the EMF measurement to the DSD. Okay, so for this presentation, we will cover 6 topics: the introduction, standard and guideline, exposure limit and exclusion zone, shared site, prediction method of EMF compliant, and on-site measurement. So actually, I will not alone. So this presentation will be covered also by our colleague, Dr. Imran from UTM, and also Puan Roha from Agency Nuclear Malaysia. So I would like to thank you for the support in this presentation. Okay, so let's go to the introduction. Okay, so as we know the broadcast working group, so under the MTSFB, so the chairman is Dr. Zakri Muhammad Saleh from Media Prima Berhad, vice chairman is Mr. Mazlan Mahadi from ITV Broadcasting Berhad, and the secretary is Ms. Syahida Sharfina Suhaimi from SIRIM, and myself as a draft lead from ITV Broadcasting Berhad. Next. Okay. Okay, so as displayed in the screen, so the purpose of this technical is to address the evaluation method of RF filtering and power density in the vicinity of radio communication station, intentionally radiating in the frequency range of 100 kilos or 1.0.1 megahertz to 300 gigahertz. Okay, so to serve as a reference document to industry regulator on the EMF exposure for compliance, also can be used by the public to identify suitable method to evaluate EMF exposure. Okay, so just for additional information, okay, during the group member has agreed to cover only the exposure for terrestrial radio and television broadcast services at the transmission antenna is visible or installed in the populated vicinity area. So we are not include the other than the services. Okay, normally the broadcast antenna is installed at the tower, normally on top of mountain. So normally the antenna, the tower is about 30 meter to 100 meter of height from the ground level. So and then the installation of the antenna to fit the coverage area of the transmission. Okay, so and then for this terrestrial radio and also television in Malaysia, so now we are only available three services currently: AM radio, FM radio, and then UHF TV. Okay, so the scope for this is to cover all these frequency, three frequency band. Okay. Okay, so next. Okay, so with the technical code, so the industry or the stakeholder can refer as a guideline for the EMF measurement from the broadcast antenna. So as a like from the CSP, for the NFE, MCMC, Malaysian News Agency, or the vendors, local council, Ministry of Health, and also not to forget the public. So during the development of the technical code, so we have conducted several meetings. So as you can see in the slide, so we have registered the new proposal on 10 November 2020. And following that, we have an 8 deliberation meeting. Then after that, so we have the progress meeting on the development of this code from 8 September until the last meeting on the 3rd February this year. So then MTSB had opened for the public comment from 8 to 12 February, and today we have the public session to target after this to submit to MGMC and for the approval. Okay, next. Okay, so in this presentation actually the technical code content of 9 chapters with and also 5 annexes. Okay, so chapter 1 to 4 is cover scope, the notary field abbreviation and term definition, where chapter 5 is explaining about the exposure limit, so the different label, the field strength, the field strength and power density to the occupational workers and the public. So chapter 6 is explaining about the shared site, so I will go this one later. Chapter 7 is about the exclusion zone. So this is the distance of the exclusion zone, the accident zone, and the safe zone for the EMF radiation. And then chapter 8 we cover the prediction format of the EMF radiation for compliance. And chapter 9 is the guideline for the on-site measure for EMF radiation. Next. Okay, standard and color. Okay, so all for the telecode is developed based on the national or international authority bodies, so such as MCMC. So this is our regulatory body, local national regulatory body. So SMC and RF, and also International Telecommunication ITU, and then the ICNIP, International Commission on Non-Ionizing Radiation Protection. This is the body of determine the level of the radiation of the EMF, and also of course in IEC, International Electrical Commission. Okay, so next. Okay, so for information, so from MCMC we referred to the MCMC division number 1 of 2010, commission determination of the mandatory standard for electromagnetic field emission from radio commission infrastructure, and then from MCMC T13 TDD 17001 02 guideline on the mandatory standard for electromagnetic field emission from radio communication infrastructure, and then most important is ICNIP guideline. So we refer to this document, ICNIP guideline 1185-483-524-2020, guidelines for limiting exposure to electromagnetic field from 100 kHz to 300 GHz, and also there is IEC 62232 2019 determination of RF field strength, power density, and SAR in the vicinity of radio communication base station for the purpose of evaluating human exposure. Okay, next. Okay, so if you see that we have in the chapter 5 and 7, so we cover calculation for the exposure limit and restrictions and rule, where the clause 8 cover the prediction method for the single or multiple antenna system, and then chapter 9 is the on-site measurement procedure and recommendation. Okay, all this item so we based on the IEC 62232, and we also cross-reference with the below document ICNIC, the ICNIC guideline, and also the ITU REC BS 1698. Actually, this is the everything fields from terrestrial broadcasting transmitting system for assessing exposure to non-ionizing radiation. Then ITU K52 guidance on complying with limit for human exposure to electromagnetic fields. ITU K100 measurement of radio frequency electromagnetic field to determine compliance with human exposure limit when a base station is put into service. ITU K61 guidance on measurement and numerical prediction of electromagnetic field for compliance with human exposure limit for telecommunication installation, and also IEC 6232. Okay. Okay, so this okay, especially okay, as we know, so this slide shown the electromagnetic spectrum that we have 7 categories of radio spectrum, i.e. from the lower frequency radio wave, and next to microwave, then category 3 infrared, category 4 visible, category 5 ultraviolet, category 6 X-ray, and category 7 is gamma ray. Okay, so this is the non-ionizing is up to the visible electromagnetic spectrum. So where we focus on the radio wave and up to microwave for this broadcast services spectrum. Okay. Next. Okay. So, okay, for this slide, so I would like to invite my colleague, Dr. Imran from UTM, to elaborate, explain about the exposure level and limit level for the EMF radiation. So please, Dr. Imran, over to you.
Okay, terima kasih Encik Muhammad Azmi. So good morning everyone. So Mr. Madam Moderator, Mr. Chairman, Dr. Zaki for the technical code, Puan Roha, the panels, and also the MTSFB management, and to all the participants who have participated participate this event today. So thank you very much, and I'm glad to share with all of you the information about the EMF, the reference level for the exposure to the EMF. Okay, this is the tables that we took from the ICNIC document, ICNIC 2020. The previous document, ICNIC was updated in 2008, but in 2020 there are a new updated document, and ICNIC is the independent research body based at Germany. and there have been a thorough research on the EMF level of exposure to the human bodies. And IGNIP document has been referred by many technical standard bodies in many countries, as well as the ITU. ITU itself also refer to the IGNIP document. So we refer the document which is in line with the ITU, and this is the table where it spell out the exposure level to the occupational workers and to the public. Of course, to the occupational workers, the exposure level is higher than the public because the workers need to come to enter the sites, and the working space is very close to the source of the radiation. There are a few ranges of the frequency bands starting from 0.1 megahertz to 300 gigahertz. If you look into the 30 megahertz to 300 gigahertz frequency, the information of the incident power density is given there, but not at the 30 megahertz and below. But at the 30 megahertz and below, they are given the information on the incident electric and magnetic field, which is from this information also we can use into the equation to calculate the safety distance or the exposure zone. Right. Next, please. All right. So we know that the radiation from the antenna, they have two regions, basically, which is near field and far field region. At the near field region, we have another two regions, which is reactive near field and also the radiating near field. The reactive near field is the region which is very, very close to the antenna, and near field region is a bit away from the antenna, but for the wave that form into the purely plane wave, basically at the far field region. So for the equation that we use to calculate this for the exposure limit, the incident power density, we're using the equation that as if at the far field region. All right, next please. Okay, so these are the exclusion zone where the area around the antenna or antennas where the RF field value emanating from the antenna exceed the IGNIP public or occupational guidelines. So if you look into the region, we have the accident zone, occupational zone, and also the compliance zone. Right. The reason why we come up with this technical code is to make sure that the public is staying at the zone that's safe to them. Also, for the workers who are going to enter the site, also they are safe to work and they are not overexposed. Okay, they are not overexposed to the EMF radiation. So that's the reason. Okay, so we use the equation of the effective isotropic rated power. And also the ERP, effective radiated power. ERP is normally coming from the concept of the isotropic antenna, which is the ideal case. It is as if for the theoretical concept, but not in the real world. But in the real world, we have the small dipole antenna, which is the distance given by the equation of the dipole antenna is more or less same to the isotropic, is slightly different. Right, when we talk about the distance zone, I think the safety distance, occupational zone. So normally public a bit misunderstanding. They're thinking that the distance zone is the distance between them to the tower. All right. So basically, tower, it doesn't radiate any signal. Okay, the component that radiates the signal is the antenna. So it's supposed to be the distance between him or her to the center of the antenna. Right. So if the antenna is installed or is located at 30 meters from above the ground, right, on the tower, so means that if the safety zone is 15 meters, so if the workers standing just under the antenna near to the tower on the ground, they are still actually safe. Okay, because they are 30 meters away, where the safety zone is 50 meters, for example. Okay, so we do some simulation to illustrate the area, the safety area. So normally at the tower, at the broadcast tower, we use the directional type of antenna, sectoral type of antenna, or the directional type of antenna. Okay, so if you use the parabolic dish, then it is a very small areas to be related, because we focus on a very small angles, right? To make sure that the power can be transmitted very far away. If you use the sectoral antenna, normally it's between 60 to 90 degrees angle of radiation. So still, it doesn't harm the. If you look into the building under the antenna, okay, the still the workspace is still safe to the workers, because the radiation is pointing to a direction where it's not direct to them, unless the antenna is pointing pointing to the building, then it's going to be another issue, right? But normally for this case, it is safe. However, in the same tower, we may have multiple type of antenna. The directional type of antenna, or maybe the omnidirectional type of antenna, right? So for that case, this is where we need to do, we can do the prediction by calculation, and we can also perform the measurement to measure whether the EMF level at the working space is safe to the workers or not. Right. So this is this technical code document is all about, right? To give the ideas, or to give a guideline on how we can provide the safe area for the people who are working in this telecommunication tower, or in this kind of sites. Right. Next, please. Okay, so this is the equation that we use. The power density, which is ERP over 4 pi d squared, which is d is the distance, the safety distance that we, accident distance that we calculate using this equation. And you can see the other equation, which is 1.64 ERP over 4 pi d squared. So as I said, that ERP is based on the isotropic concept, isotropic antenna concept, and ERP is based on the dipole antenna concept. And for this technical code, we use the dipole antenna concept, whereas ERP is normally is the value that used in this broadcast, in many broadcast technical code document, the guideline document. So that's why we choose the 1.64 ERP as over 4 pi d squared to calculate the power density, incident power density, and also to calculate the distance, the minimum distance of the accident zone. All right, next please. Okay, as I told before, we have the bands where the ERP is not given. Okay, the frequency below 30 megahertz, but they are given value of the electric incident of electric and magnetic field. Okay, we still can use this equation, this value, to this equation to calculate the minimum distance, where it is 5.5 square root of 1.64 ERP over the electric field. So by using this equation, then we can calculate the the exclusion zone for that range of frequencies. Next, please. Okay, so this is the exclusion zone distance of the highest ERP for the shortwave and FM radio transmitter station. This is the example. How do we do the calculation and table it into this table? For the shortwave radio, for example, so we choose the antenna ERP is a 59 dB watt. Okay, why 59 dB watt? We have many towers in Malaysia. So we choose the highest power that transmitted by one of the tower. We try to simulate the worst case scenario to calculate the incident zone distance. Okay, and for the frequency 5.9, for example, then we get the occupational exposure zone, which is 32.95, and public is 72.49 meters, right? But if the ERP, the power is less, then of course the exclusion zone will be shorter. Okay, so if you look into the occupational exposure at 5.9 megahertz frequency, it is 32.95. If the antenna is located at 50 meter on the tower and from the ground, so if the workers near to the tower, they still actually at the safe distance, because they have the distance from the person to the radiation source is 50 meter, but the accident zone is the 32.95 meter. So this is the example, the guideline on how we can calculate, we can predict, do a prediction on the distance. Right. However, we can confirm this over the measurement, which will be explained by Puan Roha after this. So that's how we do the same thing on the FM frequency. So both public and occupational distance for the 87.5 to 108 are same. Which is for public 37.74, and for the occupational zone exposure is 50.88 meters. So with the antenna related power is 43.39 dB watt. This is I've been told that the most highest power that transmitted by one of the transmitter that we have in Malaysia. Okay. All right. Next, please. Okay, so this is the frequency range that we use for the TV broadcast. Actually, we have many more bands, but to show the example, we choose these two bands to show the example of the calculation with the antenna ERP 51. Also, this is one of the highest power from one of the tower that we have in Malaysia. So not all the towers transmitted the same the same power. Okay, so there might be various of range of the powers, but we choose the worst case scenario, right? So if the power less than 51, then of course the distance will be shorter, right? And yes. It also depends on the specification of the antenna, the type of the antenna, whether we are using the focus type of antenna, or we're using the factor type of antenna, or we're using the omnidirectional type of antenna. So for this calculation, if for the omnidirectional type of antenna, but if the focus antenna, of course, is very much safe to the workers on site, because the point of the angle of the radiation is focusing to the other type to the other towers, or to the specific areas which is far away from the people who are work under the antenna in the base station areas. All right. Next. Next, next please. Okay, share site. Okay, this I give back to the Mr. Azmi. Thank you very much. So, Mr. Azmi, you need to unmute your microphone.
Okay, sorry. Thank you, Mr. Dr. Imran, about the presentation. So I continue with the share site. Okay, so for the share site, for the broadcast transmit antenna. So normally the antenna is installed at the pole or tower, or where the mono leg or three-legged or poly or mast type of pole. So and normally also the tower is serve more than one services, mean it has a more multiple antenna system. For example, maybe radio and radio to antenna system, or radio and TV combination of antenna. So in this case, we call it this as a share site. So when there is a share site, then it's a multiple RF owner. So in the meeting, and so in the special meeting, during the development of the technical code, so the members agreed that to determine the RF owner, who is the RF owner for that setup, for that set location. Okay, next. Okay, so the recommendation is for new site. Okay, so for if any new site, the first antenna system owner will be the RF owner. So for the next newcomer, if any newcomer, then the newcomer will become new RF owner. So the first RF owner to be transfer the ownership to the newcomer as a RF owner. And also, if there is any upgrade work or additional antenna or anything from the existing antenna owner, then also the ownership will be transferred to this the RF owner. Okay, so actually RF owner is not just a coordinator in case of any requisition from the public regulatory body for the AMF evaluation or whatsoever. So that is, we call it RF owner. Okay, next. Okay, so this topic is about the compliance for the prediction of the EMF prediction. Okay, so for single antenna system, so the assessment can be only by a calculation, but for the shared site where there are two or more antennas, then this is the assessment need to be with the advanced simulation software to assess the RF evaluation from all the antennas. Next. Okay, so there are several techniques of the simulation. So this is as you see, the near field topology open, and then the technique FDTD. Okay. Okay, actually FDTD is a finite different time domain, and MOM is a method of moment. So for this is the recommended the techniques of simulation based on the field zone. So, and then all this is okay. For more, you can refer to the IEC 62232 for about this numerical techniques. Next. Next. Next slide.
Very sorry. We are experiencing some technical issue on our side. We are getting people to actually come back. Hold on, yeah. All right. I think we are resharing or started to reshare again the slides.
Okay. Thank you, Fida.
Yeah, no problem.
Okay, next. Okay, so this is the exclusion zone indicator. So this is based on the ITUK 52 confinement zone, confinement zone and accident zone. So if we can see the red accident zone, red is an accident zone, the yellow is a confinement zone, then also the white is compliance zone for the public. So so normally, as Dr. Imran mentioned, so the radiation is exclusion zone is just in front of the antenna. Just like a broadcast transmitter. So it's transmitted horizontally or horizon. So that's why not transmit downward. It's transmitted down horizontally from the top of the tower. So normally the exclusion zone is in front of the antenna, not below the antenna. Okay. Okay, next. Okay, so this is the illustration of the multiple antenna cell at one shared site. So where so there's a receiver antenna 1, antenna 2, antenna 3. So this is just example of the radiation pattern of the multiple antenna system. So normally, so it's easily the for broadcast normally the radiation is in horizontal or horizon mode. So there's a 0 degree tilting actually, or maybe sometimes it's just 0.1 or 0.2 or 0.5 downward tilting. It's very narrow tilting to cover the wider range of area. Okay, next. Okay, so this topic we cover on-site measurement. So therefore, I would like invite Paroha to elaborate on this. So please, Paroha.
Thank you, Encik Muhammad Azmi. Okay, I will continue the presentation with the in-situ measurement, on-site measurement. Yang berusaha Puan Zaliha Abu Bakar, GM of MTSB, Management of MTSB, Pengarah DOSH, Cik Muhammad Nazri, Working Group Member, participants, ladies and gentlemen. So I will continue this presentation with measurement. Okay, this is on-site measurement where we have to go to the selected site. So the purpose of the measurement is to analyze and confirm the actual EMF exposure at site and its surrounding areas, because this is concerned for the public and also the workers who are working at the site. Okay, and the result of the measurement or the radiation level or emission level shall comply with the permissible exposure limit (PEL) as stated in the MS and also ICNRP guideline, International Commission of Non-Ionizing Radiation Protection guideline. Okay, and this can be performed. This on-site measurement can be performed at near field or at far field region, and for broadband also for frequency selective measurement. This is depends on whether we perform the measurement for public concern or for the workers who are working at the site and concerned about the EMF exposure to them. Okay, next. Okay, so for the measurement, there are some requirements for the device that we use for the measurement. The first one, the measurement device must be able to measure electric field in watt per meter or magnetic field in ampere per meter and also power density, and must comply with the ICNRP standard. It means that the equipment must have probe. We have the device and also probe, which is can measure electric field and also magnetic field. Okay, and number two, the measurement device should suit to the frequency range of the site that we intended to measure. So we can measure, follow their frequency range, which is we can conduct narrowband or broadband measurement. Narrowband means we go to specific frequency that occupied by the sites, or we can use broadband measurement where we can get or we measure all the radio frequency or EMF measure EMF level at the surrounding sites. It means that we can have the total of the EMF level at the site. For narrowband, we go specifically to the certain frequency that used by the site. And this equipment must or shall able to measure, follow the frequency range that occupied or used by the sites and comply to the characteristic of the EMF source available at the site. And during the measurement, the EMF level required to use a personal monitor. This is especially when we measure at the near field measurement, which is very near to the antenna, because this EMF level, if we measure very near to the antenna, the EMF level, it might be very high. So we need to consider the person or the personnel who monitor the or conduct the measurement, so they are not exposed to, or they have to be aware with the RF EMF level at the site. And number four is the number and the characteristic of the EMF source. This is very important to ensure that we can choose the right equipment, the right frequency range of probe, so it will suit to the characteristic of the EMF source. We need to identify the number of source and also the characteristic, the frequency, so the measurement equipment will suit to the measurement objective. And the number five is our equipment shall be calibrated and has valid calibration certificate. This is to ensure that our measurement is reliable and valid during the measurement. And number six is the field region in which measurement is made. Okay, I mentioned just now, and also Dr. Imran also mentioned about the near field region, far field region. So we have to determine whether we want to measure in the field near field region or far field region. If in the near field region, which is very near to the antenna, which is normally concerned for the workers who are working with the antenna, for example, we need to measure the electric field and also together with the magnetic field. But if we are measuring the EMF level at the far field region, which is normally we conduct this measurement for public exposure concern, we only have to measure the electric field. So before the measurement is done, we need to calculate the reactive near field, radiating near field or far field region based on the calculation that mentioned by Dr. Imran just now. Okay, next. So for the measurement method, to measure the EMF, the personnel must be a qualified personnel, which is they undergo specialized special training on EMF measurements. So to ensure that they understand the basic of the EMF, the electric field, magnetic field, how to measure, what type of equipment, how to start the measurement, how to do the analysis, and how to conduct how to draft the report and so on. So we need the person who are specialized in EMF measurement and qualified as personnel EMF measurement. Okay, and then we have to record before we started the measurement. We need to record the physical condition which is related to parameters. For example, physical condition. For example, the number of the antenna, the type of antenna, how many source, how many, maybe the single side or maybe shared side, and then we need to know the height of the structure, the distance of measurement where we put the probe, and also the distance with the within the probe and the antenna, and then the transmitting power that used by the RF source that we intended to measure. Okay, so we need to sketch, and we have all the physical condition and record it for the purpose of drafting the report. Okay, and then we also need to identify the type of the source. Okay, the frequency, and then the location, and we need to consider the worst case situation and popular public places. For example, if we conduct the measurement for public concern, we need to see around the site. We need to identify, maybe there are public places, for example, schools, we have maybe playground, we have residential areas. So, and then we conduct measurement at the few location, at the few measurement points, which is normally at least we take like 10 measurement points and map the radio frequency radiation, EMF, at the area. So this is to ensure that we can determine what is the radiation level around the place, around the selected measurement point or selected source, the broadcasting station. Okay, so we need also identify the RF, the measurement points to ensure it covers the area of the measurement. And then we perform the test, as mentioned just now, must suit with the frequency that used by the selected sites. And then we compile the measurements at least 10 locations, and then we have to plot the results. We have to analyze, and then we have to do some description on the results, and then we need to verify and the compliance level. So to meet the objective, why we conduct the measurement, we need to compare with the permissible exposure limit, whether or not it comply with the permissible exposure limit. And in the report, we have to mention, and we have to put the photo when to conduct measurements, and then the measurement method, equipment, and we have to attach together with the calibration certificate of the equipment, and then the plot, and then report and the results. Okay, so the report shall be endorsed to ensure that this measurement follow the standard, follow the methodology, and the equipment is reliable. So the result is reliable, and the report is valid. Okay. Okay. Next. Okay, thank you. Okay, back to you, Encik Muhammad Azmi.
Okay, thank you, Fanoha. So with the presentation, so we have very good information from the information how to do the on-site measurement. So with that, we are reaching the end of our presentation. So I want to thanks to all the person and so the organization involved in the development of this technical code. So they have spent their precious time during the one, so to in order to complete this technical code within the very quite short time frame. So I thank to all the members and organization. So and that I end this presentation with Assalamualaikum, and get back to the opponent Fina. Thank you very much.
Thank you very much, Encik Muhammad Azmi, Dr. Imran, and Puan Roha for the very detailed briefing on the draft technical code. Our apologies for the brief glitch just now, just one of the challenges in hosting virtual events, and thank you for staying on. It seems like we have good participation for today's session. In Zoom alone, we have more than 50 participants, and on Facebook, we are being watched by more than 20. last I checked. So great. So we would like to also welcome Yang Berusaha Professor Tariq Abdul Rahman, the Commission Member of MCMC, and our officers and colleagues from MCMC for joining us today. Also to Yang Berusaha Encik Ahmad Nazri Abdul Kadir from the Department of Occupational Safety and Health, DOSH. Thank you so much for your time today, gentlemen and ladies and gentlemen. Really appreciate it. So ladies and gentlemen, now that we have arrived at the core of our session today, which is the Q&A session, I would like to suggest for the participants wanting to ask questions to the Broadcast Technology Working Group experts to use the raise hands feature in the reaction button at the Zoom application on your PC or laptop, and we will unmute you. Please do introduce yourself by providing us your name and which organization you are from, and proceed with the question as brief as possible. And please feel free to forward your questions in either English or Bahasa Melayu. Don't worry, campur-campur pun still boleh. Next time, once I have learned other languages, Korean ke Spanish ke Chinese ke Tamil ke, I will open the floor for other languages as well. But for now, let's use English and Bahasa Melayu. And in addition, for those who prefer to type in their questions, you can do so by typing the questions into the chat section. We will then read out the questions for our panel to answer. We are also accepting questions from our Facebook page, as we are also on Facebook Live. So we will also take questions from that end as well. And in fact, we already have quite a number of questions from the Facebook page, specifically 4 questions and 2 suggestions that's being forwarded by Encik Samsul Bahari Samsudin. Maybe the team can help to actually type in the question from Facebook to the Zoom chat so that our panel can actually address the questions one by one. The first question, so generally EMF can be divided into 3 types according to the respective frequencies of ELF, LF, and RF. The first question, how does this team identify the differences in the early effects of occupational or community health as a result of 3 different EMF frequency, namely the three ELF, LF, and RF? That's the first question from Cik Sam. So maybe I just read out the whole post. The second question, has this team conducted a study to see the relationship between RF, EMF with employee or community health problems to support the permissive exposure level proposed in the guideline? Number 3, what health biomarkers can be used to identify or confirm the early effects of RF, EMF exposure on human health according to the PEL or the permissive exposure level in the technical code? The fourth question, has the study of the effects of occupational and community health on RF, EMF ever been conducted in Malaysia? According to Cik Samsul, he thinks that there are, but not too many. Perhaps this team can refer to those studies. His suggestions, the first one is proposed that studies related to health effects are also conducted by this team to further strengthen the PEL recommendations given in this technical code. And the second one is to propose that the name or the title of this technical code to be specified to prediction and measurements of radio frequency electromagnetic fields or RF EMF exposure from terrestrial radio and television broadcasting transmitter stations. So the panel, are you ready to actually respond to this?
I just wanted to make it's not really a response, but there's this question pertaining to has the team conducted a study to see the relationship between RF EMF with employee and community health problems? The answer is no, but you have to understand the scope of this document. This document is a technical code, which is actually, if let's say anybody wants to do a study, then this document outlines how the study should be done. So really, this document will not be able to cover such a huge undertaking. So I appreciate the question, but to those who want to conduct study on the community health problems, which I fully support, to be honest, then this document can be used as a reference. So to have the study itself in this document, I think is beyond the scope of this document. Thank you.
All right. Any other response from the panel? Thank you,
Yeah.
Dr. Zaki.
All right. Thank you for the question, Mr. Shamsul Bahari Shamsuddin. So when I browsed to his Facebook, then I noticed that he is one of the board of the directors for the NIOSH. So that's why the type of question is coming like this. So we appreciate very much the concern of these issues on the EMF relation to the public health. So basically, for this technical code, is developed to define or to determine the exclusion zone, the safety zone for the workers and for the public. All right, but to study the instant effect of the hats to the human bodies. Yes, IGNIC document has spelled out the EMF level exposure for the local exposure. Local exposure. Local exposure means that very close to the human bodies, like the watch, the smartwatch that we use, we wearing now, right? And all the sensors that we use near with that touching our bodies, right? That also concerned by the IGNIC document. Yes, I agree. In Malaysia, there are not many research group or research teams doing this kind of research. So I consider this is quite new to the Malaysia researchers. And I know that there are some groups of from my colleagues doing this kind of research from UNIMED. They are doing the bioelectromagnetic research, and I think they also got one of the grant from MTSFB for this, right? But they're still under study. The result is not yet matured. But for this technical code document, we need to refer to the established reference or the matured reference, which is that's why we always use the document by the ITU, IEC, and IGNIC, right? So there are another document also by the IEEE, but since ITU use IGNIC, we prefer to use IGNIC document, right? However, yes, I'm also very much interested into this bioelectromagnetic, and maybe one day we can have some platform to organize whatever conference or webinar, and we can call all together the researchers in this bioelectromagnetic, and from there we can do something to the nation. Thank you very much, Mr. Shamsul Bahari. Right.
Maybe I can add a bit. Okay. Okay. Thank you for the questions. Okay, I will answer. Give my thought as part of the questions. Okay, we understand that there are lots of concern on EMF exposure. I think started from late 90s, early 2000, where actually public start concerned about the EMF exposure because of there are so many base station near to residential area, commercial area, and also there are concern from the broadcasting industry as well. We in the Agency Nuclear Malaysia, we actually conduct several measurements, okay, from early 2000 until now, and we to address the concern, to ensure that, okay, because public also normally ask, or workers normally ask, okay, what is the radiation level or EMF exposure level around them, okay, especially members of public, because they can see there are so many base stations around them in recent years. Okay, so we conduct the measurement, we analyze the assessment, but we found that because this radiation or EMF exposure from the base station actually is low level EMF, low level electromagnetic field. So we found that the results comply with the permissible exposure limit recommended by RC and IRP.
Okay, thank you, Puan Roha. Cik Azmi, anything you want to add? Or we can go to the next question?
Here's the next question.
All right, thank you. Thank you so much, Azmi, and thank you for the panel for answering the 4 questions from Cik Samsul from UMS, Universiti Malaysia Sabah. We have the next question is from Puan Zulaika from Sirim STS. And I think from Mr. Stewart, this one is very directly related to the presentation by Puan Roha tadi, Puan Roha just now, in terms of the on-site measurement report and the training conducted by Nuclear Malaysia. So the first question from Zulaika, Puan Zulaika, in current practice, how do the RF EMF simulation report being verified? In the slide just now, it was just mentioned on the on-site measurement report. That's one. That one was taken up by Puan Roha. The second one is for the on-site measurement required qualified person to conduct the measurement. Yeah, we did mention about that. How do you define the qualified person? Does he need to attend special training conducted by Nuclear Malaysia and be certified by Nuclear Malaysia? Or does a person need to attend the training conducted by his own organization? Puan Roha, up to you.
Okay, the first question tadi on simulation verify. Is that the question? The
Yes. Yeah, how do the RF EMF simulation report being verified? Correct.
Okay, for the simulation report, I think I'm not the one should answer this question because we are not conducting any simulation at the moment. Yes, we have facility and also but we are not providing any service to the simulation report because that simulation report they need to submit to MCMC. Okay. On the second question today, okay, what how to determine the qualification of the person who conduct the measurement, kan? Okay. At the moment, actually, we Nuclear Malaysia we conduct we have training center and we conduct training on EMF assessment where we are accredited as ISO IEC 17020 on RF measurement, on EMF measurement. Okay. So actually we conduct 3 days training on theory and then practical on site measurements and also analysis and also report generating. So after they undergo that training, we consider qualified and we will give them a certificate. That is the our practice at the moment to ensure that the measurement is conducting by a right person and then use the right tools, right analysis, and then the report is we call it reliable because the methodology and so on. So that's the current practice.
Thank you, Puan Roha. Any other comments from the rest of the panel? Dr. Imran, ada? No? Any comments before I proceed to the next question?
Right. So this is about the verification of the simulation, right?
Yes, correct.
Okay. Yes, simulation basically is to give us what we call the prediction, right? So the name of the technical code also the prediction. However, in practice, I would like to recommend to do the measurement. Okay. Yes, of course, by using the simulation tool, the simulation software is is verified by the software owners, software companies, and this software actually is not is very expensive, very much expensive. I can tell you. Okay, but however, it is just give us the ideas. Okay, for the real situation, for the real input, I would like to most recommend you to perform the measurement, to evaluate the EMF level, EMF level that exists inside that you are going to measure. Okay, right. Thank you.
All right, thank you, Dr. Imran. Encik Azmi, any comments before we proceed to the next question? I'm just going around the panel.
Okay, I think we go to next question.
Next question. Okay, Dr. Zaki, last words, Chairman, anything for this question, this section?
No, I think Dr. Imran and Puan Roha has already outlined, I have given the comment. So I think it's okay. I think
All right.
Puan, let's go
proceed,
ahead to the next. Yeah.
Okay, thank you.
Yeah.
So we proceed with the next question from Mr. Stewart Sayong from the Sarawak Multimedia Authority, SMA. So, is there any charges imposed by the Malaysian Nuclear Agency? Ini memang straight to Malaysian Nuclear Agency lah ya. Charges imposed if the public request for the PL test to be conducted in their area. So tak ada orang lain lah, Puan Roha.
Okay, is there any charges lah nak buat servis untuk apa? Buat measurement, okay? Conduct the measurement. Yes, there is charges to conduct the measurement.
Okay, nanti maybe kalau nak tahu lebih, maybe Mr. Stewart boleh contact Puan Roha lah. Berapa chargesnya kan? Okay, yeah, I think we move to the next question lah. This is very straightforward. Okay, the next question is a bit more complex, yeah. So please excuse me if I salah baca ke apa. But anyway, from Mr. Leon Moon. Okay, tak tahu daripada from which organisation. Maybe you can put in the chat box later, yeah, Mr. Leon Moon. There is a table in the document which shows worst case exclusion distance for 51 dB. 51 dB is the worst case calculation. So the suggestion is to also have another table to show what are the exclusion zones given that the X power for channel 21 is scaled down from 51 dB, 50, 48 down to 20, whatever is practically used. So maybe I can ask Dr. Imran kot. Yang ni jawab yang ni dulu.
Right. So yes, we can have the other scenario, which is the power calculated less than 51 dB. Then we are going to have quite a long table in the in the TC documents, right? So right now we have, if you look into, if you please go and get download the technical code document at the MTSFB Facebook. I think Facebook is a portal, MTSFB portal. You can download the technical code document. So that the example of the frequency band that we project today to show the example. Actually, the table is quite long because the range of frequency, the band of frequency is many-most, and all the frequency bands we are using the 51 dB watt power transmit, which is the worst case scenario. If we want to have more examples, then we are going to have more tables and also more pages. That one I leave to Dr. Zaki as the person who are sharing this technical code to make a decision.
Okay, dah panggil Dr. Zaki. Please, Dr. Zaki.
Yeah. Okay. This is Dr. Leon lah. I think I know this gentleman. Thank you very much, Dr. Leon. Okay, I think as Dr. Imran mentioned lah, I mean we can have all the sample calculation, but the document is going to be quite large lah. So if you want to have a specific calculation, I think you can use the calculation formula that we have provided. So you can put in the frequency. If you know the channel, then you know the frequency, and if you know the specification of the antenna, how many dB gain and power of the transmitter, you can use the formula which is provided in the document, and you can calculate the exclusion zone. I think that's okay lah. I think that should be the way forward lah. I mean, we can have a lot of these samples, but the document is going to be quite large. The table is going to be quite large. Yeah, thank you, Puan Syafina.
Okay, thank you, Dr. Itulah. Apa ni, Dr. Leon, dia dah tambah lagi dia punya ni suggestion, suggest to do only one channel 21 frequency. That one maybe for consideration by the working group lah. Nak guna table 21, apa for channel 21 ke macam mana kan for the technical code nanti. Alright. So far, no more questions in the chat box. Let me check with my team whether there's any more questions from Facebook. Encik Samsul Bahari, dia siap share lagi the research document from ResearchGate punya link. Nanti kita akan sharekan sekali on the electromagnetic field, one of the research papers on ResearchGate. Any other questions from the floor or in Zoom? Again, you can use the reaction button, raise hands kalau nak cakap direct, or kalau malu-malu, biasanya macam I lah, I suka type dekat chat box je. Kan, lagi clear kan, and for our panel to actually refer to. So far tak ada lagi. Bagi beberapa saat lagi for anybody to actually type in questions or ataupun to raise hands. Sebentar tu I check Facebook sekejap ya. Rasanya Samsul je tadi. Thank you so much for the questions and the comments. We really appreciate it really for this session. Okay. Prof Tariq sudah angkat tangan. So maybe.
Okay, thank you for showing us, moderator. I would like to apologize that I joined a bit late just to ask questions related to the simulation and also on the measurement, on-site measurements. So when in the simulation, because basically normally we will do a simulation to a given location because we do a site measurement to every location is quite quite expensive. But when you're talking about simulation, you are considering, because two things here, when you're talking into the broadcasting, also the more important that what you are receiving on the ground from the measurements, basically is what been transmitted from the towers. And then it also depend on the antenna height. I mean, even you are talking about putting the what you call the requirement set, but you see the antenna height also play an important role because the higher you put the height, the higher you put the site, the signal receiver will be more. So the question here is that in the simulation, are you considering when you do a prediction, compare with are you considering the environmental? For example, you are looking into different environment, for example, urban, suburban, rural, they are different because they will have additional loss to deal with the environment. So in the simulation side, do you consider that? How because it very dependent on the clutter and all those environment when you are talking about, if you want to compare it with the measurement, because measurement is the actual measurement being measured from the towers. But what about when you do a prediction? You have to ensure that the surrounding area environment has to be included in order to ensure that the measurement is comparable to the simulation. Yes, thank you.
Right, thank you, Prof. So maybe we start with Dr. Zaki dulu lah.
Well, I don't have an answer to Prof Tariq punya question. But just to reconfirm, Prof, you are saying that if we were to do a prediction or based on simulation, you're asking whether we include environmental effects. Is that your question? Prof? I tak berapa faham. Maknanya,
yeah, of course. For example, you say that in one location the measurement been done, then of course there will be, of course you have to verify by the simulation verified by the measurement. But when you do a measurement, you need to include the environment, the surrounding, because otherwise the measurement that you are measure and the one the prediction is not right. Because it really depend on the environment. So that's why I mean, when you do a prediction, for example, if there are other sites where you don't need to do a measurement, because first stage to do is try to have one location to do the prediction and measurement, because the measurement is to verify. At least you can choose different environment, for example, urban, suburban, rural, different clutter, and to ensure that the result you obtain from the simulation is right. Otherwise, we are measuring something that not actual what supposed to have lah, and how we can rely on the simulation. We have to confirm that the validation of the prediction has to be confirmed with the measurement. But that's why I say that when you do a prediction in a given location, you have to put the clutter, all those environment. This is the additional loss that will contribute to the power or receive that at that location that you measure.
Yeah, okay, I understand. Prof, I'll be very honest with you. I don't have an answer to your question. I don't know. I rasa Puan Roha kot boleh jawab, because when it comes to the prediction software, we in Media Prima we don't really have that. We normally engage a consultant to do that, and we, of course, when we do that, we will ask the consultant to include all the necessary parameters inside the prediction. After we've done the prediction, we would normally also do a sample. That means we actually do physical measurement to verify whether the prediction at specific points. Of course, when we do actual measurement, we cannot do everywhere lah. That's where the prediction comes in. But just to verify, to make sure that maybe a few points, and we will confirm the measurement and compare it with the prediction. If it is okay, then we assume that the prediction is correct for all. So that's the normal way that broadcaster do it lah. So I don't know, Puan Roha or Dr. Imran, maybe you want to comment on this?
Excuse me, I comment just
one
comment.
Azmi,
Okay. So actually, if we look for the technical code, actually for the assessment or the prediction is for the exclusion zone. So not as a coverage area, but it's an exclusion zone of the antenna. So that is the main purpose of the technical code, exclusion zone. Okay, so that's answer your question, because
Sorry, go ahead. Teruskan Cik Azmi.
Teruskan.
Okay. Regarding to the simulation and the measurement, so I actually I think I agree with Dr. Ahmad Zaki just now. The current practice is like, okay, I think MCMC require the telcos or broadcaster to send the EMS simulation report to MCMC, I think, and then it is good to have check and balance, to have real measurement to check or to verify the simulation results or simulation work provided by the telcos. Some sort like we call it measurement audit to verify the simulation.
Just that was important. It's just we want to ensure the simulation prediction use, considering all those information. So when we obtain the prediction result, it is close to the measurement. And when you're looking into the prediction, meaning very dependent on the environment and the clutter and all these things, which means that in the technical code, as they mentioned that all the prediction software or prediction done to verify have to include all those things. So otherwise, you won't have the correct value. Maybe different if you go to measure, and then because we are measuring exclusion zone, we are talking about where the people are receiving those what you call the level. But that's why we have to ensure, because most of the location site will be done by simulation or prediction. That important, the measurement is to verify that. And it's important the package used in the prediction has to meet to ensure that the things that, for example, you're talking about urban, suburban, or even rural, or it will be different because if you're looking into the same condition like a free space, or it doesn't matter anywhere, it's the same. That's why we have to ensure in the technical code that the prediction use has to meet that requirement, meet those what you call the clutter, the everything. They need to have even the database of the surrounding area put into the simulation before they can predict the actual value. Okay.
All right, Prof. Thank you very much for your suggestion. Yes, I think for those who are not familiar with the simulation, there are a software for the propagation path loss calculation, where this software is it is very high-end software. It is quite complicated, where we have to put all the terrain information, all the information about the building that we have, every building. So with the height of the building, type of the material, whether it is a tree or it is a building. So we have to put just like it is a very complicated and complex software, but it can give us very accurate information about the propagation path loss. So maybe not many people are exposed to this kind of software. So normally we are in the university. I think not many universities also have this kind of software, and it is good. Because before this, maybe when we do the simulation, we just do a simple simulation with there are no environmental information, just a building, the towers, and the people. Okay, and we do the calculation. But of course, in real situation, there's a lot of things having in our environment. So we take this suggestion, Prof. Into the committee meeting. We are going to have next round committee meeting before this technical code endorse. We will submit to the MCNC for the endorsement, and I will highlight these issues in the meeting. Thank you, Prof.
Okay, thank you, Brian. Just to make sure that in the technical code for the prediction simulation, we have to mention this. I mean, the software to be used, we have to include all those things. Thank you.
Means that we need to define the right software that are going to be used in this prediction measurement. Okay. Thank you, Prof.
Okay, thank you.
I was told that Cik Haji Azlan is the simulation person here, expert here. Is Haji Azlan is present? Ada?
Halo, ada. Yes.
Tuan Haji, boleh tolong shed some light pertaining to the Prof Tariq punya question on inclusion of environmental parameters in simulators.
Hello, Assalamualaikum.
Waalaikumsalam.
Okay, pertaining to Prof Tariq question is basically the simulation software we are also include on the environmental such as building structures, and also the vegetation surrounding area. But to do that, it will look like very complex report. We have done this before. It was last 2 years that we submit to MCMC, and basically what we get from MCMC is they said these are too complex, and telcos could not do this because it's very costly. So what we did is we do the worst case scenario. We take the high maximum, and then we propagate. We do the propagation, and we get the result based on worst case scenario. And basically, the result will not be the same as what we do when we on-site measurement, because on-site measurement is depending on the usage of the antennas. What simulation do is only on based on worst case maximum output. Is that answer the question?
Okay. I don't know. Any comments on that? Siapa? Anybody? I think back to you, Puan Syafina. Let's go to the next one, I think.
All right,
Okay.
thank you so much.
Just to comment on that.
Yeah. Great.
Yeah, I
Yes.
think what you mentioned, you're talking about worst case scenario, meaning that the measurement you done will be less compared to the prediction will give the worst case, which means as long as the prediction level you are receiving is still within the limit, is acceptable. But I want to ask Farwaha, basically if you do, normally you have a simulation, then you do a measurement at that site. How is the result? How is is comparable, or because if you say that the prediction based on the worst case, meaning that it should be higher than what the actual been measured. Is that the case you are mentioning from your previous experience of the measurement?
Prof. Tariq, thank you for the question. Actually, okay, agensi nuclear normally dia kita buat pengukuran measurement on-site measurement. Tapi kita pernah buat study, we try to simulate. We found that the simulation because of the condition is tak sama, not same. Simulation normally they use the highest transmitting power, if not mistaken. Both still far below the permissible exposure limit. We found that the simulation is much lower compared to the real measurement. But we are not doing many sites. We just try to compare a few sites before. We found that okay, the permissible the simulation result much lower compared to the measurement.
You mean the measurement result is lower? I mean lower than the prediction result is lower than the measurement.
Yes.
Which means it didn't underestimate. I mean, it didn't. What we are talking about, we are looking into the worst case, meaning that the measurement actually lower than the prediction. That will be covered under the safe side lah. But because it's important, because most of the location we don't go and do the measurement, we do a prediction only before we want to set. No, that's why we want to ensure that the prediction is closely or represent what the actual is supposed to be when the site, when the actual towers is there. Okay, that's why. Thank you very much. Just my comment only. Just to ensure that where the prediction done at the real location is closely, acceptable with what the actual things that we are supposed to receive at those locations. Okay, thank you.
Yeah. Prof, actually, I agree with you. On your point, memang I agree. I mean, if for us, we don't want to unnecessarily endanger the public when it comes to RF radiation. So I pun terkejut juga bila Puan Roha kata that normally the measurement is always higher than prediction value. But I guess this is an interesting fact. So maknanya we cannot 100% depend on prediction alone. It has to be verified through actual measurement. So I think that is the point that is yang kita belajar lah from this. So I don't know, maybe after this we can take this up again in the committee meeting just before we finalize the document. But I think, I don't know, I open it again to the committee if there's any other further comment.
Or maybe I would like to interject here. Maybe we can take it during the working group discussions. We
agree.
noted on the comment. Okay, thanks Dr. Zaki and Prof. Tariq for the comment. Maybe we'll take one last question from Dr. Nordin. Dr. Nordin dah lama dah angkat tangan, but we are actually almost at the end of our session. Maybe we make it brief sampai 11:50 if we can. So maybe Dr. Nordin, the floor is yours.
Assalamualaikum, selamat pagi semua. Saya bercakap ni campur-campur, okey ya. Saya actually saya cuma ingin by the way saya from Consumers Front of Sabah lah, Consumer Association di Sabah lah. So actually yang saya nak tanya ni is the current situation. Yang tadi yang saya dengar semua ni is the future untuk buat research dan sebagainya lah. Tapi what is important to us now is the auditing part. Adakah satu-satu badan dalam Malaysia ni dia pergi buat auditing di mana-mana site ataupun we totally depending on the government to do it? Because kita tahu dia signal-signal ni semua dia boleh increase, dia boleh kasih kurang power, dia boleh macam-macam lah. Jadi itulah yang kita pihak kami mau tahu ni, is there any special bodies that do the auditing and give the result checking, or selama ini memang tidak ada langsung yang daripada badan-badan untuk buat the auditing. That's all. Thank you very much.
Okay, thank you Dr. Nordin from Sabah. Boleh bah kalau kau boleh. Tapi I think it's a similar question to the question from Puan Salwa Denan in the chat box. Once the on-site measurement has been conducted and report prepared, who will be conducting the report verification or the auditing before submission to MCMC? For example, is it Nuclear Malaysia ke or any other bodies ke? Mungkin the panel boleh jawab.
Okay, mungkin saya boleh jawab lah kot. Nanti orang lain boleh tambah lah, panel yang lain boleh tambah. Okay, thank you Dr. Nordin Tani daripada Sabah ya. Okay, is there any organisation or authority yang buat measurement ataupun audit on the EMF exposure kan? Okay, so actually Nuclear Malaysia, we actually we are government agency who actually concerned about the EMF because we are this EMF is we call it non-ionizing radiation. So for the radiation which is fall under Nuclear Malaysia jurisdiction lah to take care. So we actually conduct the non-ionizing radiation from low frequency because I heard one gentleman tadi mention about ELF semua kan. Okay, so we conduct ELF, we conduct RF around Malaysia. So because this is not mandatory, so we actually pick up this issue based on the complaint of from the members of public or any concern, maybe from the telcos, from other bodies who concerned about the EMF exposure to the members of public especially. So we besides of public complaint, we actually also previously worked very closely to MCMC and we conduct several measurements, for example for the whole of Penang, and then now we have I think in future we have for the whole of Sarawak, and then for the whole Malaysia. Actually Nuclear Malaysia is the one who conduct the assessment, and we actually accredited ISO IEC 17020 for RF measurement, the first government agency and the only organization has this certification, this accreditation for conduct RF measurement. So normally public channel it to telcos company, maybe to the authority, the local council, to MCMC, to maybe the politician and all that, addressing their concern. So they will channel to Agency Nuclear Malaysia to conduct the measurement. Some sort of to ensure and to measure the EMF level at the selected site or the site that people are concerned. We measure and then we conduct the report. We conduct the assessment analysis and then we produce report, and we have we call it RF certification for that particular site. So mana-mana site yang telah diukur, kita akan beri dipanggil sijil pengukuran, maksudnya for that particular site lah, for that for certain period, for example. Okay, and then tadi siapa yang endorse report tadi kan? Okay, who verified the report? Okay, so at the moment the current practice, because of this issue is quite very long time, and now at the moment Nuclear Malaysia endorsed or verified the report, because we now not only Nuclear Malaysia conduct the assessment, but we also do some kind of training to certified personnel to conduct RF measurement assessment, to ensure that the personnel is trained, well trained, and then they use the correct methodology, and then the right equipment, and then calibrated equipment, and then they know about the permissible exposure limit, which is must comply with the MCMC and also International Commission for Non-Ionizing Radiation Protection, ICNRP. Means they know, okay, for example, kalau kata ada share site kan, we have like Maxi Celcom together, for example, a few okay, which permissible exposure limit that they need to choose to indicate the result of the assessment at that particular. That is very important for the verification, to ensure that the report is reliable and the report is valid. Is that answer the question?
Alright, thank you Puan Roha. I think memang menjawab lah tu, dah ada sijil pengukuran semua kan. And also the verification kan. Yes, so yeah, Puan Salwa pun dah cakap thank you. Alright.
Puan
Okay,
Syafina.
Yeah,
okay, I understand that we are running out of time, but just a quick nak confirm balik dengan Dr. Nordin tadi. I think Dr. Nordin, you are talking about auditing, right? Dr. Nordin?
Yes, that's it. Auditing.
Yeah. Okay. So from the logical standpoint, kalau before you set up any RF device, you kena minta license daripada MCMC. MCMC is the license body. And then dalam application you ada specify what is the ERP, what is the power and stuff like that. So the license is awarded based on your parameter that you have given. So if you ask me, the person that is the body that should do auditing would be the licensing body. That should be MCMC lah. And I believe MCMC ada buat auditing. Cuma I don't know how extensive the auditing process is. So I don't know, any rep daripada MCMC, or maybe we can take this offline kot, since masa pun dah tak berapa mengizinkan. Am I right on that, ni Dr. Nordin?
Yes. Correct. You're correct.
Okay. All right. Thank you, Dr. Zaki, for the additional explanation. Yeah, I think we can take it offline jugalah. It's part of the consideration of the technical code overall and the discussion in the working group. So again, thank you so much for your active participation, ladies and gentlemen. With the last question just now being answered, that concludes the Q&A session for today. So next, before we go to the wrap up by Dr. Zaki, we would like to share a simple tutorial video on how to comment on technical codes. So kalau tak sempat nak cerita pada hari ini, kita boleh komen kemudian ya. So please enjoy the video then. So that's it for the tutorial video, just a fast one. Hope it will help those wishing to contribute more comments to the draft technical codes. So to wrap up the Q&A session and also the public engagement session for today, I would like to invite Yang Berusaha Dr. Ahmad Zaki to conclude and summarize the overall Q&A and the public engagement session for the technical code today. The floor is yours, Doctor.
Okay, terima kasih Puan Syafina. Okay, I have nothing much to say, but again, I would like to thank you, Puan Zaleha, our General Manager of the MTFSB, and of course, my BT working group, with especially the head drafting committee, Encik Azmi Zahid. And I would like to also thank everybody here today, everybody who has attended, especially those who have made comments. Thank you very much. We value your comments so much. I will promise you that after this, during the next concluding committee meeting, after this, we will definitely review back all the questions that have been posed. If there is further clarification, we will contact you individually and we will re-clarify. So all the questions, rest assured, will be considered very seriously. So thank you, everybody. I forgot to thank you one very important person, Cik Hafiz. Cik Hafiz, who has been very from MTFSB, who has been very actively arranging all the meetings, gathering all the people. I have been in the many years of my involvement with MCMC and MTFSB ni, I know betapa payahnya nak organize meeting ni. It's not easy. Dengar kata organize meeting senang, tapi you know, to get people's time is really not that easy. So Cik Hafiz Halal, thank you very much for your effort. I don't think we can come up with this document without your involvement lah. And of course, Puan Zaleha and your team, thank you very much. So I think other than that, I have nothing more to say. Again, thank you very much, and over to you, Puan Syafina.
Thank you, Dr. Ahmad Zaki, for the wrap up and your kind words. So before we end, we would like to have a short photography session with all of you, the participants here today. So I would like to request for everyone who is able to switch on their video, to switch it on now so that we can take a group photo of the participants. Kita ramai hari ni, 50 orang kan, more than 50. So yeah, thank you again for participating. So semua dah pasang ke video? Kita tengok gallery view. I bagi 3 saat je pasang video. Cik, kalau nak konon-konon nak adjust tudung ke apa ke kan. Ataupun baru nak make-up sikit ke, Zoom dia ada function untuk ni touch up. So boleh touch up lah dekat online tu. Okay. Semua malu-malu ni. Tak apa. No worries. Kita shoot nama pun shoot nama je lah. Oh, video control. Admin. Boleh. Admin tolong allow. Thank you for the feedback. Patutlah. Diorang tak malu. Diorang nak buka. Admin. Mari kita tengok. Okay. Cantik-cantik background masing-masing. Thank you so much everyone. Ada yang daripada rumah. Rumah cantik lah. Ada yang daripada office dan sebagainya. Thank you so much for joining today. Thank you so much everyone. Okay. Ready eh? Alamak, kamera broken. Alah, beli kamera baru lah. Mesti jalan ni. Okay, admin ready Kita screenshot. Ready everyone. One.
Yes.
Yeah.
Okay, smile. Ready.
Smile.
1, 2, 3. Okay, hold on. Okay. Another shoot. Okay, ready. 1, 2, 3. Alright.
Thumbs up.
Okay, thumbs up. Okay, ready. 1, 2, 3. Alright. Thank you.
Alright. Thank you so much, everyone. So that marks the end of our public engagement session for today, but I still have some housekeeping punya messages. So before we go off, for your information, the presentation slide yang tadi tu that we shared just now will be shared on our website, and the recording of this session will be available on our Facebook page. So we would also really appreciate it if you can give your feedback on this event particularly by clicking on the feedback form link in the chat box. I hope it's already in the chat box. And also either by scanning the QR code displayed or shared on the screen. Tunggu admin share. Mana QR code dia? But you can give your feedback regarding this event through that form. In addition, you are all invited to submit comments again for this draft TC until 15 March 2021 via the comment form at our website mtsfb.org.my or by following just now the steps shown in the tutorial video earlier. So very easy, 1, 2, 3. Just download, review and submit your comment. So on behalf of MTSFB, I would like to thank all of you for your support to this event, and I hope to see you all again in our future events. With that, Assalamualaikum warahmatullahi wabarakatuh, and have a very good day ahead. Thank you.